Hello everyone, and welcome to a lesson on four-term factoring. I know we haven't touched three-term, two-term, or three-term, two-term, or one-term factoring, but it turns out that four-term factoring is actually one of the easier polynomials to factor. Now, before we get into what it is, I just want to remind you guys that we've actually, in a way, already done factoring for polynomials. We've just done the opposite, where we've been multiplying. When we factor, remember factoring is the opposite of multiplying in a way, where I would start with this polynomial and my goal is to get into the situation where we have these two binomials multiplying in parentheses. So our goal is what's in the parentheses, all right? And we're starting with what's right there. So for us to actually factor the four-term polynomial, what we're going to do is we're going to start with this four-term polynomial right here. And I am going to, there are two ways to do this. First way is by grouping, and the other way is by box method. So what we talk about for grouping, guys, what we do is we take the four-term polynomial, and we just put parentheses around the first two terms and the second two terms. And then what we're going to do is we're going to slowly find the greatest common factor of each pairing, just like we did in the previous lesson. So if I focus just on this first set of brackets, I'm going to look at the numbers first. What goes to 10 and 15? Oh, that's going to be 5, right? Okay, that's pretty good so far. Let's look at the x's now. How many x's could go into x to the 3 and x squared? I could take at most 2 x's from both, right? Because once I take away 2 x's from x squared, I'll run out of x's. I have to take it out from both. So this is the greatest common factor of this first parentheses. And in a way, we're going to do is like the opposite of the distributive property here, where I'm going to start a parenthesis and I'm going to put the leftovers in. So if I take 5 out of 10, I'm going to left with a 2, right? So 2. Now, how about x squared? How many x's I'm taking out of x to the 3? I take away 2. That leaves me with a single x. Now we're going to have plus. If I take 5 out of 15, divide by 5, I'll get a 3. And if I take 2 x's out of x squared, I'm left with nothing else, right? So I'm going to close that parenthesis. And boom, what we just did there is to find the greatest common factor of these two, which is what we did in the previous lesson. Now, let's try that with the second one. Ignore those. Let's look at the second one. We'll look at just the numbers first. 4 and 6. What is the biggest number that goes into 4 and 6? Oh, that's just 2, right? And notice how the first term has an x, but the second term doesn't. So I don't have to worry about x's at all. I'm going to start my parentheses now. 4 divided by 2 is 2. Nothing happens with the x because I didn't take an x out. And then 6 divided by 2 is 3. So, boom, I just found the greatest common factor of both sets of parentheses. Now, here's how you tell if you've been doing this right by factoring. Notice how this is a 2x plus 3 and a 2x plus 3. Boom, right there. Because these are the exact same things in the parentheses, I can combine these through addition because effectively they are now like terms. It's like adding 3x plus 2x equals 5x, right? Nothing happens to the parentheses, but I'm going to be able to add the terms that are in red now, that are on the outside. So 5x squared plus 2 is just 5x squared plus 2, right? And then nothing happens to the 2x plus 3, so I'm just going to put it right there on the side. And voila, it's been factored. And if you want to tell if you got it right or wrong, guys, you can go ahead and use FOIL and multiply this out, and you will get what we originally started with. Remember, guys, factoring is rewriting what we start with as 2 or more things being multiplied. Boom, right here. These 2 things are being multiplied. Now, I know some people don't like factoring by grouping, so I'm going to show you guys another method, which is the box method. Do you guys remember we used the box method for multiplying? What we're going to do now is we are going to do the opposite, where I'm going to take all these 4 terms, and then I'm just going to put them into the box one at a time. 10x to the 3, 15x squared, 4x, and 6. 4 terms, 4 boxes. So now that I'm done with that, what I'm going to do is I'm going to try to figure out what's going to go on the outside. So instead of it being multiplying, guys, when we multiply, we had stuff on the outside, and we had to figure out what goes in the box. Now we're going to start with the box and what's going to be on the outside. So I'm going to start with just looking at this first row, and we'll look at the numbers here. 10 and 15. What goes to 10 and 15? Oh, that's 5. Okay. And then we look at the x's, and I see it's x to the 3 and x squared. So I can take up to 2 x's out of both, right? And that's it. 5x squared should be on the side. Once you have one of these guys, it becomes a lot easier, because think of it this way. 5 times what is 10? That's going to be 2. X squared times what is x to the 3? That's x, and you'll see that it also lines up with this. 2 goes into 10 and 4. X goes into all of these. Now 5 times what is 15? That's going to be 3. 3 goes into 15 and 6 also. And x squared times what is x squared? Oh, that's going to be 1, so it's not going to be x's next to that. Okay, so notice that we have everything on the outside so far except for what goes here on the left. So now, guys, think to yourself, 2 times what is 4? Isn't that just going to be 2? And 2 goes to 4 and 6. And notice how everything matches up now, right? Because 2 times 3 is 6. 5x squared times 2x is 10x to the 3, so on and so forth. Once I have all my answers, I can just take what's on the outside and put them in the parentheses. So we have 5x squared plus 2 in one parenthesis and 2x plus 3 on the other parenthesis. So you don't have to do both of these methods. You only need to pick one, okay? So pick your favorite and go ahead and solve those problems. I want to see the work, guys, for you to get full credit, okay? If I don't see any work, no credit. You guys have a good day. Bye.